Let's look at this question now. Now that we've solved it algebraically, let's look at it graphically. And honestly, you could do this several different ways. You can do this as y1 and then graph it. You can do this as y2 and then graph it. Honestly, I really think that if you actually bring all of this over to one side, and remember that this is 2 sine squared x plus sine x minus 1 equals to 0, and find the zeros is going to save you a whole bunch of headache, because then you're not graphing two graphs. You're only graphing one graph. That to me makes a whole heck of a lot more sense. So how do we go about doing this? Well, remember a couple things. First things first, this is in radians, and we gave our answer in radians from our algebraic answer, which is these three answers right here. So that must mean that in this nice little beautiful 2 pi graph here of the period of 2 pi, I'm going to have 3 intersections because I am finding the zeros of the graph. Right? Yeah, baby, let's do it. So let's take this guy and let's put him into our calculator right now. So, boom. Make sure that your calculator is already set up. Yep, I've got them in radians. That's great. Now, with that in mind, then, I want to also remind you of what my window settings are. My window settings are from 0, and lo and behold, that looks like 6.28. Yeah, that's 2 pi, right? 2 times 3.14, right? I'm going up by my favorite scale, which is pi over 6. My y min, my y max, everything looks good. Let's start throwing the equation in there. Now, remind yourself of what the equation is. The first part of the equation right here is 2 sine squared x. Let's throw that in the calculator. Okay, 2 sine. Now, do I square it right here? No, that doesn't look right, because look, the square is inside the brackets. So that's not right. So let's go. 2, and how you do a square is very interesting. All you got to do is put a bracket. Hit sine x, okay, just like you would normally hit sine x, but put the additional bracket. And that's what's going to be confusing, is you got to have all these brackets around things. Why? Because you're taking this whole sine x here, and now you're going to square it. Boom. See what it looks like now? Yeah, the whole thing is squared. You see it? Okay. Now, the second part of this was plus sine x minus 1. Okay, let's put it in there. Plus sine x, perfect, minus 1. There's our nice equation as a degree 2 equation. Graph it. Let's see what it looks like. Oh my, 2, just like oh, look at that. Isn't that cool? Just like we predicted. There's 1, 2, 3 intersections. Now, the thing is we got to find out what those intersections are. Okay, same as you always did. These are all zeros now. They're not intersects. Sure, they intersect the x-axis, but on this calculator, you got to figure them out as zeros. Okay, so second calc, find me the 0. 2, let's find the first one. Let's go all the way back here. Left bound, just like we did in Math 20. Look at this, so much fun. Enter, guess. You got it. This works out to be 0.5235. But remember, this is in radians. So again, go back to your calculator here. Okay, clear all this stuff out of here. Now, hit x equals 2. There it is. That's in radians. So that has the pi in it. So get rid of the pi by dividing out the pi. Perfect. Gives you that. Frac it. Math, frac. Boom, look at that. You got 1/6. So your answer, in fact, here is going to be, yeah, pi over 6. And look at that. Confirmed. Beautiful. Okay, keep on going. Let's see if we can get the 5 pi over 6 and the 3 pi over 2 now. All right, here we go. Back to the calculator. Find me the graph again. Find me this second intersect, okay, or the second 0. Mouse it over, left bound, right over there. Enter, right bound, right there, enter, guess, and you get 2.61. Yeah, okay, whatever. So go back to your calculator here, right? Go x equals 2, x, enter. There it is. Remember, that's a radian, so we got to divide out the pi, okay? And now we get this ugly thing that I'm pretty sure that we can make into a fraction. Math frac, there it is, and I got 5/6. So check it out. This is now our 5 pi over 6. Confirmed. Okay. Last but not least, let's see if we can get that 3 pi over 2. All right, here we go. Clear this guy out. Go back to our graphing calculator. Second calc, find me that 0, which is at 2 here. Mouse it over. There's my left bound right there. Okay. Enter. Find my right bound right there. Enter guess. And look at that. I got it 4.712. Oh, yeah. Okay. So back to here. Second quit. Okay. X equals 2. Bada boom. Okay. Divide out again that pi value to give you something that looks like that. Well, that looks pretty close to that being a fraction, doesn't it? Okay. I don't know if this thing is going to actually do this into a fraction. Let's see. No, you know why it's not going to do this? Is because this calculator in its beauty also has its faults. That should have been, yeah, look at that. 858, that should have been 9999. This shouldn't even have been 999. That should have actually worked out to be 1.5. So if you ever get something that looks like this, where it's repeated, 99999999999, just round it. It's 1.5. So if I was to put 1.5 into here and math frac it, look what happens. Watch. There's my 3 over 2, just as I predicted right back here. So this becomes 3 pi over 2. Yup, that confirms. So we see a lot of really cool things on this graphing calculator, don't we? Okay, we see that it actually has some faults, but we still haven't drawn the grid. We haven't drawn this graph on the grid. So let's do this. We know that this is at pi over 6, 5 pi over 6, and 3 pi over 2. I'm curious. Because my graph is going up by pi over 6's all the way up, what is this in terms of pi over 6? Well, simple. Multiply that by 3, you get 9 pi over 6. Aha! Now this becomes really easy to graph, right? So your first point is going to be pi over 6. It's going to be right there. Your second point is going to be 5 pi over 6. So there's pi over 6, 2 pi over 6, 3, 4, 5 pi over 6. There's my other point. And the other one's at 9 pi over 6, okay? 6, 7, 8, 9 pi over 6. Remember what this graph looked like? Oh, I don't know. There it is. Whoop, right there. Boom. Come on, you. There it is. Okay, so it comes up, intersects through here up to this way, gets to a maximum value. I don't know what that maximum value is. Hey, I got an idea. Why don't I use my calculator and actually figure out what the maximum is? Second calc, find out that maximum. Boy, this is looking an awful lot like parabolas that I did in Math 20-1, doesn't it? Yeah. Enter, right side. Enter, find me that maximum. That maximum looks like about 1.57. Interesting. Okay, so let's go up to here about 1.57. So about there, a little bit higher. Yeah, about there. There's our maximum there. So I know that this guy is going to start down, way down below here. It looks like it's starting at -1. It's going up to the 0 there right off the bat. So it's starting here, going up to the 0 here. I also know a couple other things about this. This guy's coming down here, okay? All right, perfect. Let's go. Oh, looks like this is at 2. Oh, I made a mistake here. Let's go back to here for a second. This is not at 1.57. This is at 2. So it's way the heck up here. What am I talking about? 1.57. Okay, 1.5. I don't know what that is, but I know it cuts about here. So I'm going to look right at the middle, and I'm going to say the middle, right about there. So check this out. Look at that. That's going to come down here. Now, the problem is we know that this guy's going to hit a minimum down here. Let's figure out what that minimum is, and let's not get messed up on that one. Second calc, let's find that minimum, which is 3. Bring this guy down. Left bound, right bound, just like before. Use your calculator. That's what it's made for. Left bound, right bound, enter. Look at that. I got 3.39, but I got negative 1.125. So it's not going to be too crazy. It's going to be just down to here. Just down. Oh, I'll use red. Just down to here. And a little bit over, and then back up to here, and then rounds out and goes down like that. Oh, that's a real pitiful diagram. But oh well, that's the best I can do in terms of the sketching. So that's how you solve it. That's how you graph it. And yeah, it makes a lot of sense, doesn't it? And it's beautiful because after all, our graph actually confirms that we got the right algebraic answers.